I am Srinivas Nimagadda. I am a product line manager in VMware. The product I manage is the baby here. It's called as NSX Distributed Firewall. With me, my partner in crime is Anirban Sen Gupta. He is the director for engineering in VMware. Anirban, you want to say a couple of words?
Yeah, so I work, as Srini said, director of engineering, and I'm responsible for this product. So the only thing I wanted to say in the beginning is we started off saying from the keynote that this convention is all about defying the convention, right? And this is one of the products you would see which really defies convention here. With that, I'll hand it over to Srini to go through the presentation.
Okay, thank you, Anirban. Okay, so what we want to cover today is we want to have a brief look at how we have done data centers for the past multiple decades, right? Hey, this is how you do data centers. This is the three-layer architecture and all those things. And try to point out that with the evolving themes in terms of how applications are developed, built, and deployed, how things have to be relooked at, how things have to be changed. And then we transition into the product-specific stuff of what are the features, what is the functionality, what kind of benefits you can get out of this product line. And then I'll transition over to my colleague there, Anirban, who is going to talk you through the architectures, the packet paths, and all the fun stuff about the real stuff, right? And then we are going to wrap it up by having a look at how this is really going to change the dynamics in terms of how you're going to deploy your firewalls. Is it how it is going to be changing the way you are going to think about security for your data centers. Make sense? Okay. Let's look at this picture that you already seen in the keynote earlier, right? So what we are trying to do in the data centers is we want to enable applications to come up live as fast as possible. This is not just spinning up VMs, but this is also about connecting the networks, making sure that the security is in place, and the entire end-to-end life cycle of an application, right? For this to happen, the current deployments in terms of compute obviously enables you to do it based on the virtualization of the compute that happened about 8 to 10 years back. But the other components in the data center that are also critical for this, including the network and security and storage, all these pieces are making things harder for you to enable application instantiation in a faster way. What you'll see here is, hey, I need to bring up this application, but for me to connect the network connectivity will take about a week, right? And then if you actually look at the security team will say that it will take about 10 days for them to secure that particular application. So while bringing up an application itself is pretty fast, the other pieces in your data center are kind of slowing it down, right? So with that, let's actually take a step back and look into the security angle of this. This is the data center deployment that we are all aware of. We have done data centers like this for many, many years. So the core layer, the aggregation layer, and the access layer, typically the security services hang on the services and aggregation layers. What I want to show here is the traffic path of traffic coming in from outside the data center into an application that is hosted inside the data center. So let's start with the packet that originated outside and reaches an application that is hosted on one of your virtualized applications, right? So this path that goes through a core layer aggregation and then access and hits the application, this in my opinion, this is kind of the right way of going through the firewall and getting the traffic inspected there. But if I look at the other angle of application that is hosted inside your data center, trying to talk to a component that is also inside the application, inside the data center, the path typically goes through from the virtualized layer all the way to aggregation, hits the firewall inspects with the same set of rules, and the traffic goes to the destination. Right? Of these two paths, the first one is kind of optimal, but the second one of traffic talking between components inside the data center, that's not optimal because whereas this communication can happen direct, we are actually forcing it to go and hit the data center firewall because you want to have a single place where you want to do the traffic controls. To look at why this. Why this matters, right? The first thing is a long time back we used to do a lot of applications that are client server, right? All these applications that are client server, the client resided outside the data center, your application that is hosted inside the data center was the server. The traffic paths were mostly, if not all the paths, were north-south, right? Going from that client, coming down all the way to your server, and the server responds, one request, one response. So the life was happy there. And then came this enhancements in the application architectures where we introduced applications which are three-tier kind of an applications. One request that is coming from the client to your server, a web server, internally could translate to multiple requests to your app server. And each request to your app server from the web server internally translated to multiple requests to the database, right? So the point I want to make here is a single request that a client is making to a server internally translates to many, many, many requests of communications across different components inside the data center, right? If we actually look at the more recent applications, Web 2.0 portals or any of these things, this problem gets even more important because a request to the portal now is not just a request to one application. Internally, there are portlets, and that one request could translate to request to the chat server, request to the enterprise directory server, and many of the other application communications. And each application itself could be a three-tier application. So that one request that we are making to the portal could internally translate to probably 100 internal communications, right? And one other thing that is happening is not just about how applications are built, but also about how applications are deployed. Whereas traditionally an application meant one server, now an application is actually virtualized on a server. So each host could host many, many of these VMs. And in many cases, if the VMs are hosted by the same host, the traffic could originate from the same host and come back to the same host, but you are forced to send the traffic to your firewall because that is a place where you enforce the traffic controls, right? This is taking suboptimality to the extreme, right? So VM to VM, ideally this traffic should not even hit the wire because the VM is on the host, the destination VM is on the host, and you could put controls right there, right? We are now forced to send the traffic to the firewall. The other part is because the original firewalls were now loaded with both the north-south traffic as well as east-west traffic, those firewalls are becoming more of a choke point, right? Both in terms of performance and scale, as well as in terms of the complexity of the rule tables that you are enforcing in that firewall. Note that this firewall is fundamentally built for IP address-based world. So these firewalls don't really understand what a VM really means. You can't, for example, write rules based on the VM names, VM tags, VM attributes, none of those things, right? So the enforcement that you're doing at the data center firewall, first of all, you are actually impacting the performance and scale of that box. And secondly, you are also impacting your own experience in terms of operationalizing that firewall because the rules, you are forced to write the rules based on IP addresses, whereas there could be potentially better ways of doing this, right? So as an industry, we realized this problem about 4 or 5 years back. I'm sure that we at VMware, as well as some of the other vendors, came up with solutions that said, okay, now let's not have this traffic punted all the way to the data center firewall. Let's try to enforce access controls in the virtualization layer. But our first instantiation was something like this, that the firewall now runs as a VM, right? This solved a lot of problems in terms of traffic steering, but it also did not solve some of the other ones, like, hey, this firewall is running as a VM in the user space, so it is not optimal in terms of performance and scale. Because you want to consolidate the multiple applications onto the same server, now you have to worry about not just about how much of the applications are taking in terms of CPU and memory utilization on that host. In addition to that, you also need to worry about the traffic profiles of the VMs that are hosted on that host and see if your firewall can actually pass the amount of traffic, right? So, and then because it is a VM, you have some of the issues that are related to VM. What happens if this firewall goes down, high availability and other issues around that VM. So we took a step back and said that for the virtualized world, there should be a much, much better way of addressing the security needs, right? So we gave this as a charter for our great engineering team led by Anirban, and said, hey, can we look at this and try to come up with something that is more fine-tuned for data center deployments for virtual world, right? So what we came out with is the thing that we announced today. It is called as NSX Distributed Firewall. This firewall is embedded right inside the hypervisor, right? It is embedded right inside the hypervisor. It is a hypervisor-based firewall, right? So why does it matter? It matters because it is built right into the hypervisor. The kind of throughput performance that you'll see out of this box is at the minimum that we are looking at. I'll let Anirban comment on this later on. 15 to 30 gig of traffic on one host, right? It is pretty huge compared to the VM-based performance profile. In addition to that, if you're spinning up a new VM on top of that host, there is no way that VM can actually circumvent the firewall rules that you wrote because all the traffic that is coming into the host will get inspected by the firewall that is built in. On top of that, this is better compliance because you can't have a rogue VM that is coming up on that host and trying to go around and figure out what other applications are running on your system, because any VM that comes up on that box gets inspected. There is no way of circumventing the firewall. Right? The other way of looking at it is traditionally we did this huge monolithic firewalls that is right at the center of the data center. All communication has to go through that one firewall. Now what we did was we broke up that as a big box firewall and we distributed it across multiple hosts. Actually, even inside a host, we distributed across multiple VNICs. So if your VM has a VNIC, the actual access control happens right on the VNIC, right? This is super powerful. On top of that, what we did was we didn't want you guys to actually log into each host and muck around with firewall rules. We enabled you to write a centralized policy using our management solution, right? So distribution in terms of enforcement and centralized management in terms of management experience. This is kind of the best of the both worlds, right? And where is my choke point firewall here? I actually don't see a choke point firewall anymore, right? What is the scale out experience now? Traditionally the way the firewall vendors sold you firewalls is you hit your 10 gig limits, you have to kind of repurpose that firewall and then get a 20 gig firewall, right? So there is no repurposing firewalls here, right? Repurpose is a vendor terminology for throwaway, right? So in this model, as the data center applications grow, as the requirements for your throughput grows, all you need to do is add one more host, right? And instantiate the firewalling on that host. One other point I want to make here is that with the centralized firewall model that we all deployed, right, irrespective of where the communication transaction is originating, you have to send it across the wire and get it centrally inspected in one place, right? In this model, because the firewall is actually distributed, the enforcement happens closest to the source, right? If the VM is initiating the traffic, it happens right at the VNIC of that particular source. And in case the traffic is coming in from your physical world, I'll take questions at the end. In case the traffic is coming from the physical world and hitting the VM as a destination, it gets enforced closest to that VM, right? So enforcement happens closest to the source or the destination, whichever comes first in this particular case. There is no enforcement in a central place. Again, management centrally done, but enforcement done in a distributed way, right? On top of that, what is possible in this world is you don't need to actually have racks and racks of servers allocated to specific tasks in terms of VMs. What you could do is logically assign which VMs on which hosts are related to your dev test versus which hosts and which VMs are related to, for example, production, and logically segment them out and write access control rules in the same place. Right? This segmentation can obviously be based on IP addresses and VLANs if you really want to do it that way. Again, it is suboptimal. But you could do it in a lot of other constructs like VM names, VM attributes, and other things. Right? The other aspect here is as the VM gets vMotioned and moves into a different host, the rules kind of follows along, right? So you are not logging into the firewall and then making rule changes for you to move an application from one host to a different host. The last point is sorry for that. Okay, is enforcement that is done not just based on the VM names and VM attributes, but also based on user identification and user groups. Right? I'm sure that majority of you have followed the theme in the industry, which is identity-based access control. What is possible here is you could write rules based on user ID or the group that he belongs to in Active Directory. You could say marketing folks can access marketing applications, define your marketing applications, and say engineering folks can access engineering applications, and they can't step on each other, right? And the fun aspect of this is you could also extend it to not just the scenarios where the user is directly logging into the network, but also the scenarios where the user is logging into VDI kind of an infrastructure, because the enforcement is happening at the VM layer, right? VDI is an extension to desktops in the virtual space, so you could actually put a firewall right there, the same firewall, right? You could segment traffic both based on the user IDs as well as the VM names. And in the logging, we actually show which user accessed which resource at what time. In addition to that, because we are VMware, we could actually introspect inside the VM about which application this guy is actually accessing. We could even show the name of the exe file that opened that port at that point of time, so that if there is a mismatch of application names and the port numbers, you could actually figure out in the logs of why a particular application has opened up that particular port. One other scenario I want to highlight is this notion of encapsulated traffic, whether it is GRE, whether it is VXLAN, or whether any of the other encapsulation technologies out there. Enforcing traffic control on the wire becomes more difficult, because an original packet that is starting off with a VM1 and destined to VM2, for example, gets encapsulated on the wire, and based on the encapsulation, the source IP and the destination IP gets rewritten. And if you're writing your firewall rules based on the original source and original destination IPs, your firewall will not be able to enforce the traffic controls in the right way. So because our firewall executes the access controls on the VNIC at the VM level, we do the access control before this encapsulation happens. So all your access control rules are still relevant. You don't need to worry about what are the VTEP endpoints, right? You could write rules based on the VM IP, VM names, and VM tags. Again, this is not just related to VXLAN, but any of the other encapsulation technologies. All of this functionality tied together with central management, central monitoring kind of functionality with syslogs, and ability to this management solution is integrated as a plugin inside vCenter. So you could write rules based on vCenter objects now. You could say data center 1 can talk to data center 2, but only for as a backup, right? You could write rules based on the cluster names and other elements that are already defined in the vCenter. You don't need to recreate all those objects. Full RBAC separation in terms of what a security administrator can do versus what a VI administrator can do, the basic stuff that is expected for enterprise deployments. On top of that, audit logging that actually shows you what kind of changes a user did, which user logged in, and what kind of rule changes that particular user did at any point of time. So the bottom line is this is a full-feature end-to-end solution that that provides centralized management functionality and distributed enforcement functionality. Right? On top of that, we realized that the story that we are telling so far is really a pure firewall kind of a story. But in the data center security space, firewall is one important piece, but there are other critical elements as well, like host-based enforcement of security, antivirus, and vulnerability scanning, and DLP kind of technologies out there. So we partner with some of the key players there to provide much more powerful, rich end-to-end experience in terms of pulling together these technologies. There is a very specific session on this partnerships. So if you guys are interested in this, I encourage you guys to go to the partner forum. In the network security space, again, when the traffic is passing across trust boundaries, probably the traffic is going from non-PCI to PCI kind of trust boundaries. It is possible to use our technology to redirect traffic to IPS because PCI says IPS is mandatory, right? So the bottom line here is we are looking at it as an end-to-end security architecture where our firewall plays a really critical path. With this, I'll hand over to my colleague here, Anirban. Now talk about how we actually implemented this stuff.
Thanks, Srini. I think like a year or back, sometime back around that time, the Srini and the other PMs came up and says that, so we have so many issues with the centralized firewall, hairpinning and stuff like that. So why didn't you figure out what is the optimal and let's just think out of the box. So I talked to the engineering team and we were thinking about how to do this, and there are all these issues. We send traffic there, whether it's in the access layer, multiple access layer. So after some time, it dawned to us that, why send traffic to a firewall? Why not get the firewall to the VM? So the whole paradigm shift which we did, and we are introducing it in this VMworld, is in place of trying to move traffic to a firewall, we bring the firewall with the VM. And as Srini was saying, that whenever traffic leaves the VM, it hits the firewall. There is no way to escape that. The VM moves, the firewall moves. And it's not just now only on the firewall, right? What we are trying to do is basically the end-to-end security policies moves with the VM. It's on the VM, it moves with the VM. Wherever it goes with the VM. So with that, so today we are talking about the logical firewall piece of the whole NSX stack, right? Here, what we looked at is, okay, we are going to move the firewall to every VM. I'm sure you guys have like tens of thousands of VMs. Now, that has bigger problems, right? So the basic thing what we need is a centralized management to manage all the firewall policies. So what we provide is a fully centralized management. It has the user interface, which is completely integrated with the vCenter. It has RESTful APIs, which can be managed from one point of control, right? Also, it has rich dynamic containers support. So for example, as Srini was saying, that you can say that, okay, all these VMs which are in this tier, right, has this firewall policy. And any new VM comes up, right, it automatically gets the policy. The main thing here is that whenever the VM comes up and sends the first packet out, it goes through the firewall. There is no way of any packet to escape the firewall. So the other pieces which we are doing today is we have partnered with different networking vendors. Some of them I have named here, McAfee and Palo Alto Networks. And we integrate with them in the management plane, control plane, and data plane level so that we can provide really optimal level of all the way from management, policy interaction to data path. And I'll also show some of the troubleshooting and visibility which we have brought in. The next piece which is key here is we have a scalable control plane. Now we have a centralized management, one place, right? And then we have tens of thousands of point of enforcement in the firewall, right? So what is key in the middle is the scalable control plane, which takes that centralized rule set and sends all the right rules to the right VM. So this is very key here, right? Because you have the 50,000 or whatever number of rules on the top, right? Every rule is not pertinent to every VM that is coming up in the system. The control plane's job is to figure out that what are the pertinent rules which needs to go on what host and what VM in particular. So at the end of the day, what can potentially happen is you have a 50,000 rules which can come down to 500 when a VM or a VNIC is concerned. So for that, we provide a centralized controller-based approach where it sends it to every host. Each host has a local controller where it will take that and it will put it on the right point of enforcement, and then it will dynamically distribute it to those VNICs, which is the point of enforcement. And last but not the least, we have a completely distributed data path. The whole data path is in the hypervisor. It sits right at the VNIC where the packet has to go through. There is no redirection, nothing. It just goes through in the normal path and gets firewalled. It runs at line rate with very high CPS, and also there are things like it is IPv6 compliant. We have ALGs which are supported, so we have a long list of ALGs. We again do IP spoofing, and the key important part here is that it has seamless vMotion support. So what happens is because we have moved the firewall with the VM, when the VM moves, guess what? The firewall moves. All the policy moves. All the state moves. There is no disruption of traffic, right? The whole state, the rules, the containers, everything moves with the VM, and the VM just can't get out of the trust boundary. So let me go through the central management quickly. The big things here is that this is the screen you see. This is in the vCenter, which you guys all know and love. We also do the two types, which is the L2 and the L3. So you can also do MAC-based zoning, right? As well as, so you can do MAC-based boundaries. You can also do L3, L4-based ones, and identity-based ones. So here, quick one I want to just show is that you can have the rules which are based on VC containers. You can say clusters, data centers, port groups, VXLAN boundaries, any other VC containers you can use. You can use VM containers, so you can have VM names. You can say that this is my tier 1 app for this particular tenant, and a new VM comes up on that tenant with that VM. It is automatically has the policy. No manual stuff anymore. It can have VM tags. So for example, right, if a VM becomes infected and you say that, okay, this particular VM has some kind of a virus on it, it can automatically be quarantined with policies. VM attributes can be there. Next, we support identity. So you can have rules which says sengupta@vmware.com can access something, or groups, you can say engineering@vmware.com can access something. One thing here is that we support identity as natively in the data path. The next thing which is you can configure IPv6 rules here. You can have different types of ports, services, custom services. You can have IPv6 services, so you can say like neighbor discovery and stuff like that. On top of that, this is the key thing which we introduced, where you can say that I want these policies only to be on this particular entity, which can be, say, a vWire or VXLAN wire. So I'll give an example. If you have like 2 VXLANs and they have IP addresses which are overlapping, right? So what you can potentially do is you can say that these rules say port 80 allow on this VXLAN, and then on the same IP addresses, and you can say port 80 deny on the other VXLAN with the same IP addresses. So it takes care of all, means you don't have to think about overlapping IPs, you don't have to think about overlay networks, encapsulation, none of that, because it is just at right when the packet leaves the VM or enters the VM. So the next is the scalable control plane. So here what we have is that you have the APIs, which are the NSX APIs, right, which come down either from the UI or from the RESTful APIs, right? They can be like a huge major list. Generally, most service providers and enterprises have a big list. It comes down to the NSX manager, which holds the desired state. It is put in the database. Once it is in the database, then it is sent to the controller. The controller works on that rule, figures out what is the boundary of that rule, and what are the hosts where this rule is pertinent. Then a smaller form of the rule goes to the local controller, and the local controller dynamically figures out that which VMs are affected by these rules. And then it takes only the pertinent rules, puts it on the VM, actually the VNIC of the VM. So I'll go a little bit deeper into the data path also. So this is a very high-level picture. So if you look at it, here there is no picture of routers and switches, aggregation layer, nothing like that, right? The firewall sits exactly on the VNIC, right? When a packet leaves the VM, it straight goes to the firewall, right? The firewall looks at the rules, applies whatever, whether it is going or not. It goes to the other VNIC, right, where it is going to the firewall rule, and it is whether it is applied or not, and then it is allowed and it goes to the destination VM. So same way, the return traffic comes in, it looks at the state, right? When the state says that allow, it goes and to the other VNIC, and in the other VNIC, it looks the same, and the return traffic goes back to the source VM. So in this case, the packet doesn't leave the host. Not only that, it just not leaves the hypervisor. At no point, the data packet leaves the hypervisor. So if it is the VM is across two hosts, so it will go to the hypervisor of that particular ESX. Then it will go out to the other VNIC. There the firewall gets applied, and it goes to the destination. Same way, the return packet goes the same path, looks at, and comes back. So, and when the VM moves, in this case, this whole tap, right, moves with the VM. So there is no way it can really get out of its trust domain. So some of the few things on the troubleshooting I want to show, we have something called a flow monitoring. So now you have these tens of thousands of enforcement point. We get all of that, and we are putting it in a centralized place, right? And you can do aggregation. You can do details. From this screen, you can go and add rules. You see, oh, there is something here, and I want to go and add rules, right? And oops. How do I play this? The other thing which you can do is now you have an aggregation of rules, right? But you have 10,000 enforcement points, right? What we do is you can go and click on a VM, a VNIC, right, and say, I want to look exactly what is happening on that VNIC. And you will get something like this, that for every, like it's like continuously refreshing, and it will show that which all connections are new, which all connections are just got closed, which are connections were already there. So what we call it as the live flow monitoring. So from operations point of view, on a very high level, you get the whole bigger picture. You can dig down a little bit, and you will get a picture which says, okay, these are your flows on particular VM. But if you really want to see real time, you can click on the VM and it will show you exactly what is happening real time on that VM. The other thing which we do is we integrate with other external log analyzers and like Log Insight and or Splunk, right? And you would see things like this. And in this case, the things which are important here is we go by the rule basis. So if there is a match or if there is a drop, right, it's going to tell that exactly which rule matched, which cluster, which VM. It identifies it to that granular level. So with that, I want to also say that how we are providing an end-to-end solution. As Srini was saying, that it is not just a firewall solution. We partner with other vendors like Palo Alto and McAfee to begin with. Right? We have a full integration from the management plane to the data plane. So like if you go to like Palo Alto Networks Panorama or McAfee's NSM, right, it will go and talk to the NSX manager, right, and it would provide a unified view of the management. It will provide saying that, okay, these are the templates available, these are the rules which are available, and when anything changes on the NSX manager, all those container details are sent to the Panorama, and then it applies the rule on the Palo Alto NG firewall box, right? So we have management plane integration. Then the data plane integration is basically when a guest VM, the packet leaves, it goes to the distributed firewall. If the distributed firewall say pass, right, it goes to the Palo Alto. It's a Palo Alto. It's in the kernel. We have a tap filter, right, where you can add rules saying that I only want this traffic to go to Palo Alto, right? So what we call it is selective redirection, right? Say, for example, for most of the cases, just the distributed firewall is good enough. But for certain cases like HTTP traffic or chat traffic or particular you want to send it to Palo Alto, only that traffic will go to Palo Alto. So that it is not crimped. Right? So it goes to Palo Alto, it comes back, then if it is a PCI traffic, it has to go to IDS IPS, so only that traffic will go to McAfee or any other IDS IPS vendor. And once that is inspected, it goes out. So with that, I'll hand it back to Srini so that he can sum it up.
Okay, pretty cool, huh? Okay, we talked about what this product is about. We talked about the kind of problem space that we looked at and how we tried to approach this as a solution. And the question really is, how does it matter to me, right? How does it change the dynamics of how I deploy my firewalls? So what I want to do here is walk you through a few pieces. The first around access control, right? This is a much better, more secure way of doing access control in your data centers, period. Because you're not writing rules based on IP addresses for traffic that is really VM to VM, you're now writing rules that are more meaningful, rules that are based on user identification, rules that are based on VM zoning, rules that are based on VM names and tags, right? The rules that you write are enforced in a distributed manner across, and there is no way of a VM circumventing these rules. So this is by far the most secure posture that you can ever get. On top of that, we talked about how we are working with host-based security vendors as well as network-based security vendors to pull together other use cases in terms of enhanced security for your enterprise. We did not really go through a lot of use cases in terms of how firewalling can be done along with vulnerability scanning, for example, right? A vulnerability scanner tagging a VM as vulnerable because it does not have a particular patch level, and then firewall enforcing access control for that quarantine zone. So this notion of integrated security is something that is very, very difficult to achieve unless you go for a solution like this. Top of this, agility. This is at the heart of what we're building here. Because the moment you bring up a new application, it has to have the right security posture. The moment you are vMotioning that application to a different location, it still have to have the same security posture. As a security practitioner who was in security field for about 15, 20 years now, I can say that this is the right way of doing security, right? And then we also look at performance and scale, right? This firewall is not going to impede your ability to host multiple VMs on the same host when the host itself is not running out of CPU resources. The kind of throughput that we are seeing, initial internal testing is 15 gig plus. We are working with Breaking Point to actually get validated numbers here. 200 connections per second on a per host basis. This is amazing, guys. This is amazing. Because you look at the data sheets for some of these big box firewalls, 200K connections per second is huge. And getting that on a per host basis is impossible, right? So great job, Anirban. And then because you're not punting your traffic across multiple layers in your data center, but getting the traffic inspected right at the source, the latency numbers that you'll see, if you have some kind of a latency important kind of an applications, the latency numbers you'll see is microseconds. We're not talking about multiple hops impeding and milliseconds kind of latencies. We're really talking about microsecond latency firewalls, right? This is unprecedented, guys. Scale, complete new paradigm of how your firewall is going to scale along with your data center needs, right? You're not going to throw away your existing firewall and bring a bigger box, bigger refrigerator, right, so to say. But instead, you're going to scale by adding more hosts. Does that sound familiar with adding more hosts to basically get more out of your compute? The same way, you're going to add more hosts to get more firewalling, right? Pretty simple paradigms. And it also changes the dynamics in terms of how many VMs you can consolidate on a per host basis, right? Because the firewalling is done right inside the hypervisor, and it is promised to deliver so much performance. You don't need to really worry about your firewall being a bottleneck for your ability to consolidate VMs onto the same host, right? Again, we inside VMware, we are extremely excited with this kind of a solution. We know that this is going to set the trend for the industry. And with that, the last piece I want to mention is that we talked, in this session, we talked at a higher level what this product is, what the goal and directions are. But there is a subsequent session that I'm going to host on Wednesday that is really going to drill into the operational aspects. How do you write a rule? How do you write an object? How do you troubleshoot? What kind of tools exist, right? The actual hands-on kind of a thing. That's on Wednesday. The session is SEC5894. And there is a group discussion that my other colleagues are going to host around the distributed virtual firewall, right? So with that, we can take some questions. And good questions get a T-shirt. Yes, sir. Okay, so the question is, I talked about management integration with vCenter. What is your story around vCloud Director and other cloud portals, right? So as Anirban said, we expose full REST API for every single piece that we do here in terms of adding objects, adding rules, modifying object definitions, and everything. And we are working with vCloud Automation Center and vCloud Director folks to actually enable direct integration into our solution. Yes, sir. So the question is, will the rules replicate across vCloud hybrid? I'm not completely sure. I'll ask Anirban to actually answer that question.
Yeah, so VCHS basically, we are working with them to integrate on that front, right? Because this product is like GAing now, so we are going to work with them once we have the GA solution.
Yes, sir.
Sorry. Who?
Okay, guys, the question here is, how does this product relate to...
Last question he made.
Sorry.
Thank you.
Okay, the question from the front row is, how does this product relate to vShield app kind of a product line? So this is the next generation version, so to say, for vShield product lines. Because now the implementation is right embedded into the hypervisor instead of being as a separate thing. So and it is also yeah, go ahead.
Yeah, sorry. So just to give a little bit color on that, basically it's a straight upgrade, right? So whosoever is using the vShield app product, right, can directly upgrade to this distributed firewall with very minimal downtime.
Okay, go ahead, you coordinate it.
Mm-hmm. And so a typical firewall today is your default gateway, and it also performs your NAT functions.
Right.
NAT 6.4, IPv6 traffic. Are these functionality embedded here today with this distributed firewall, or is it in the roadmap?
Sure, that's a good question. So the question is, hey, firewall typically is a default gateway. And inside that default gateway, typically also do the routing kind of things and NAT translations, etc. So the question is, what is the story in terms of layer 3 services like those? What we have here is two products, right? Very similar to the vShield app and vShield Edge kind of a thing. There is an edge component for this story that does NAT translations, that does all the routing kind of things. And the component that we talked about here in this session is more of the VM level access control kind of a component, right? So, yeah, that component is also part of an NSX. Yes, sir.
I'll keep looking.
Yeah, so the question is, will there be any mechanism to import rules into this firewall so that you can leverage your existing investments in terms of building the right rule sets for the existing products? So what we do support, I encourage you to show up in the 5894 session, is this ability to export and import rule bases. The export and import happens based on XML files. So you can custom craft the XML file so that things can be imported back into this domain. Is this included in the vCloud license?
No, this is part of the NSX product, so it needs the NSX license. Not this particular one. So the vCloud suite, the vCloud suite license comes with the vShield app product.
We'll take somebody at the back there. Yes, sir. Yeah, so the question is multi-tenancy scenarios, can you write rules that are specific to that tenant without impacting other tenants kind of a thing? It is definitely possible. The way we build the management experience so far is for the service provider to log in and write the rules that are separated out for each tenant. What it means is that we expect the service provider to be a little bit more careful of making sure that things are not overlapping, etc., right? Anirban did talk about overlapping IP addresses and ability to write the rules that are specific to the VXLANs that may be assigned to a tenant, right? So using those constructs, you can definitely address the service provider scenarios. Actually, as part of the deep dive session that I'm talking about on Wednesday, I am covering one topic around service providers. How can they achieve tenant separation using this product line? Yes, sir.
You told us the NSX firewall built into the hypervisor.
Yes.
Do you guys have any statistic or data? How is the implication to have a firewall right in hypervisor? Do you notice any slow performance downgradation and especially reliability of hypervisor to have a firewall built in? And as well, as a customer, do I have a choice to run a clear hypervisor or from now on I have firewall built in right now?
Sure. So the question is, good question. Do we have any? So the question is, now that the firewall is embedded inside the hypervisor, what are the implications in terms of performance, scale, reliability, and all the other things for the hypervisor itself? So this is a great question for Anirban to take.
Yeah, so there were a few other questions, right? So the thing is that one is the performance part. Yeah, so the performance part is basically what we are looking at is with the firewall or without the firewall, right? We are looking at something like 5% hit on the throughput. That is what we are looking at, and we are well below that. On the reliability part, that it is part of the ESX, right? So the assumption is from internal, external, the assumption is it's as robust as ESX itself, right? So we go through the whole process because with the platform, right? So the whole reliability, availability part is with part of the ESX, and so it should have the same reliability requirements. It has the same reliability requirements. The other part is the question about whether you can bypass the firewall. Yes, right? It is a module, right, which you can choose not to use. So it is not that it has to be used, but obviously it has all its benefits to be used.
Yes, sir.
Yes. Is there any like roadmaps for bringing NSX with SRM or failover?
SRM.
Firewall moves over to your side too?
Yeah. So the question is, are there any plans in terms of extending the firewalling to the DR side? The answer is definitely yes. So we can take this offline and then figure out the use case that you're actually trying to solve with this solution. Yes, somebody back there.
What kind of controls do you have in place to make sure that your server administrators don't bypass the security controls by putting your VM over certain servers?
Okay. Yeah, I'm so surprised that it took so long for us to ask this question, right? So the question is, what kind of controls exist to make sure that your server administrator is not overwriting the rules that are written by the firewall administrator? So I tried to cover a little bit in my part of the session that role-based access control is pretty fundamental to our story here, right? The reason is multifold, one of which is now the same management solution will be used by networking guys to virtualize networks, by server guys to virtualize the servers, and also by the security guys to write the access control rules. So ability to separate out who can do what without stepping on each other is pretty important for this solution. You could define which user is a security administrator and say that only security administrators will be able to write rules. Right. Yes, sir.
So about 3 to 4 years ago, we were put in a position to actually talk about that with the virtual distributed switch, and out of that came a architecture system with 1000B. And it seems like now as virtualization engineers, we're asking folks to back in with our networking folks, which in most large shops are always segregated. How would one take the approach with the networking team to basically get buy-off on such a new platform that goes against the networking tradition that's been around for many years?
Sure. So the question is, we are used to doing networking in a particular way for multiple years. So how do we teach our networking folks to do the things in a different way? So the real answer for that is the value proposition of network virtualization that spans across networking and security and storage and everything as applicable for your data centers, and the value that it delivers in terms of ability to spin up applications in seconds and minutes instead of 20 days, 25 days, is a value that you need to weigh over the kind of additional learnings that your teams have to do, right?
Yes, we just have to come to VMworld.
Yeah. Okay. Yes, sir.
Is it a station firewall, or are you just looking at the first packet from each form to determine whether it's allowed or not?
Okay, so the question is it a stateful firewall, or are you guys looking at just the first packet? This is a full stateful firewall. There is no first packet kind of logic here, right?
Yeah.
Actually, the packet path that Anirban showed talks about the return packet being inspected with the state table, right? So this is a full stateful inspection.
Yeah, so just to add color on that, it's like not just the return packet and the state, right? It like we are testing against all kinds of attacks like snoop attack, land attack, frag attacks, and all those kind of things. We support ALGs, right? So dynamically, if it is a FTP port is allowed, right? When the FTP data port is opened, we are going to punch the hole automatically. So it's full featured firewall.
Okay, 3 more questions, guys.
I had the last one. Sorry.
Okay. Okay, so the question is, your stateful firewall, how are you maintaining the state across VNix? So, Anirban?
Sorry, I didn't get. It's a state table per VNIC. Right. So what we can do generally, which a lot of firewalls don't do, is basically we can so because the whole thing is supposed to be going towards a self-service. So the database, the people who are deploying the database, right, they can put rules which are based on the VMs which are part of the database, and then somebody else who is deploying the app tier, right, can write rules which are on the apps. Right, so because the state is maintained on the VNIC, right, they are separate.
Okay, so last question, guys. Yes, sir.
Since this is tied to NSX, if I don't buy NSX, then do I continue to use field app? Does that go away?
No, it doesn't go away. So the VCNS license, right, still supports the vShield app, right? And it works the same way. If you want to go to NSX and buy the NSX license, right, it's transparently upgradable.
So both continue in parallel?
Yes, both continue in parallel.
Okay, thank you very much, guys.
Thank you. So we'll be here for some time. So if you guys have more questions, please come over.